Today we are going to discuss the shrinkage limit test. This test method D4943-02 was developed by the Bureau of Reclamation as an alternate method to test method D427, which uses mercury as part of the procedure. Mercury is highly toxic to body tissues and can be readily absorbed into the body by way of the respiratory and digestive systems as well as directly through the skin. The term shrinkage limit, expressed as a moisture content in percent, represents the amount of water required just to fill all of the voids of a given cohesive soil at its minimum void ratio obtained by oven drying. The shrinkage limit can be used to evaluate the shrinkage potential, crack development potential, and swell potential of earthwork involving cohesive soil. So this is the real application of the shrinkage limit. The moisture content of a pat of wet soil is determined. Then the moisture content lost to dry the soil to a constant volume is determined and subtracted from the initial moisture content to calculate the shrinkage limit. The volume of the dry soil pat is determined from its mass in air and its indicated mass when submerged in water. A coating of wax is used to prevent water absorption by the dry soil pat. The initial moisture content of the soil is adjusted to a consistency that would require about 10 blows of the liquid limit device to close the groove along a distance of 13 mm. The dish which is used in this test, a circular porcelain or monel metal milk dish having a flat bottom about 40 to 45 mm in diameter and about 12 to 15 mm deep. So shrinkage limit SL as per ASTM D427 or ASTM D4943. The shrinkage limit is defined as the moisture content in percent at which the volume of the soil mass ceases to change. So the shrinkage limit, I will repeat that it is defined as the moisture content in percent at which the volume of the soil mass ceases to change. Now here you can see the soil which has been placed, the wet soil which has been placed in this porcelain dish. The soil volume is V1 and the soil mass is M sub 1. And when it has been dried completely, in that case the soil volume is V sub F or U and the soil mass is equal to M2. So you can see here this is V sub I, or you can say it is V1, the original volume of the soil, wet soil, which is present in this porcelain dish, and V sub S is the final volume when it has become fully dry. So shrinkage limit is W sub I in percentage minus delta W in percentage. So this is basically the moisture content of this in percentage, this soil, and delta W is basically the change in moisture content from the initial moisture content to the moisture content at shrinkage limit. So you can understand this thing from this. Actually, when the moisture is high, your soil is in the liquid state, and as the moisture is reduced, you would find that there is a decrease in the volume of the soil, but it will be continued up to this point, and then further drying will not cause any decrease in the volume of soil. So this particular point is the shrinkage limit. Or in other words, you can say it is the particular moisture content at which soil changes from semi-solid to solid state. So this is the typical trend of the cohesive soil with the decrease of moisture. So this particular point is giving you the shrinkage limit. And somewhere here you are having the plastic limit, and this is the liquid limit. Keeping this in the mind that liquid limit is the moisture content at which soil changes from liquid to plastic state. And plastic limit is the moisture content at which soil changes from plastic to semi-solid state. And I will repeat, the shrinkage limit is the moisture content at which soil changes from semi-solid to solid state. We can also write the formula of the shrinkage limit in this form. This is the initial moisture content of the soil, that one in this case, and this is the volume of the soil minus Vd. Vd is the volume of the soil when it is in the dry state. It is being multiplied by the density of water rho W and divided by M2. M2 means the mass of the dry soil, or you can say MS, that is the mass of the dry soil, into 100. Or you can write this formula like that. This is M1, M2, M2 being multiplied by 100, and this is V1, Vi and V sub F and divided by M2. So what is M1? M1 is the mass of this soil. M2 is the mass of the dry soil, and V sub I, that is the initial volume of the soil, this one, and V sub S, this is the final volume of the soil. So one thing that you can see from here, that volume of the soil at shrinkage limit is equal to the volume of absolutely dry soil. So this is very, very important. And in fact, this concept has been used to determine the shrinkage limit. Or you can say that these formulas or these equations which are written over here, those have been developed based upon this concept that the volume of soil at shrinkage limit is equal to the volume of absolutely dry soil. Here in this table, different minerals are mentioned, and correspondingly you can say the shrinkage limits are mentioned. So in the case of mortmaronite, which is the most active clay mineral, the shrinkage limit is minimum out of the three cases, 8.5 to 15. Procedure. Select a shrinkage dish and record its identification, designation, and its volume. The volume of the shrinkage dish is used as the volume of the wet soil pad. Lightly grease the inside of the shrinkage dish. Determine the mass of the greased shrinkage dish and record the value as the mass of the empty shrinkage dish. Place in the center of the dish an amount of the wetted soil equal to about 1/3 the volume of the dish, and cause the soil to flow to the edges by tapping the dish on a firm surface cushioned by several layers of blotting paper or similar material. Add an amount of soil approximately equal to the first portion and tap the dish until the soil is thoroughly compacted and all included air has been brought to the surface. Add more soil and continue the tapping until the dish is completely filled and excess soil stands out about its edge. Strike off the excess soil with a straight edge and wipe off all soil adhering to the outside of the dish. Determine the mass of the dish immediately after it is filled and record the struck measure value as the mass of dish plus wet soil. Allow the soil pad to dry in air until the color of the pad turns from dark to light. Oven dry the pad to constant mass at 110 plus minus 5 degrees Celsius. Determine and record the mass of dish plus dry soil. Drying the soil pad in air may produce cracking of soil due to rapid moisture losses in dry climates. If this problem is encountered, it may be necessary to dry the soil in a humidity controlled environment. In this case, it may take 1 to 2 weeks for the color of the soil to turn from dark to light. Determine the volume of the dry soil pad as follows. So this point is very important. Securely tie the sewing thread around the soil pad. Immerse the dry pad of soil in molten wax, holding the dry pad with the sewing thread, completely coating the pad. Do not allow air bubbles to develop in the wax coating. If air bubbles are present, use a sharp object to cut out the bubble. Refill the hole with wax. So there is one important note is written. You can take it as a precaution. The melted wax and associated equipment are hot and care should be exercised to avoid burns. Remove the pad of soil from melted wax and allow the wax coating to cool. Determine the mass of the wax coated pad of soil in air and record the value as the mass in air of the dry soil and wax. Determine the mass indicated when the wax coated pad of soil is suspended from a balance while submerged in water bath. Make sure that there are no air bubbles clinging to the surface of the wax coated pad or thread. Record this as the mass in water of the dry soil and wax. Now in the following slides you would find some information about the calculation work. So first thing is calculate the mass of the dry soil pad as follows. M sub s is equal to m sub d minus m, where m sub s is the mass of the dry soil pad in grams, m sub d the mass of the dry soil pad and shrinkage dish in grams, and m means mass of the shrinkage dish. So in this way you can determine m sub s, that is the mass of dry soil pad. Then next is the calculation of the moisture content of soil at the time it was placed in the dish as follows. So initial moisture content you can say. So W here in the formula means moisture content of soil at the time it was placed in the dish, porcelain dish or shrinkage limit dish, and M sub W, that is the mass of the wet soil and shrinkage dish. So you can see here m sub s is also involved, and you know m sub s is the mass of the dry soil pad as we have already defined. So in this way, by using this you can determine the moisture content of the soil at the time it was placed in the dish. Then comes the volume of the dry soil pad. This is also very important. Calculate the volume of the dry soil pad and wax as follows. So by using this formula, and you can see here V sub dx, it means the volume of dry soil pad and wax in cubic centimeter, and in the formula you can see m sub sx a, that is the mass of dry soil pad and wax in air, and m sub sxw indicated mass of dry soil pad and wax in water, and rho w is the density of water. So in this way you can calculate the volume of the dry soil pad. Assume density of water equals to 1 gram per cubic centimeter. Corrections for temperature may be used if desired. Calculate the mass of wax as follows. M sub x is equal to m sub s x a minus m sub s. Here the new thing is m sub x, that is the mass of wax in grams. Then calculate the volume of wax as follows. So this formula, or you can use this one, and here V sub x means the volume of wax in cubic centimeter, G sub x the specific gravity of wax, and rho sub x the density of wax in gram per cubic centimeter. So in this way you can calculate the volume of wax. Next is calculate. Next step is just to calculate the volume of dry soil pad as follows. So V sub d, that is the volume of dry soil pad, that is equal to V sub dx minus Vx, where this V sub d, as I have already mentioned, this is the volume of dry soil pad in cubic centimeter. Then comes the real thing, that is the calculation of the shrinkage limit. So SL is equal to this W minus here V, initial volume of the soil, this is the volume of soil when it is dry, M sub S the mass of dry soil, rho W is the density of water. So SL is the shrinkage limit, and the new parameter which is present in this formula, that is the volume of wet soil pad, and that is equal to the volume of the shrinkage dish in cubic centimeter. If desired, calculate the shrinkage ratio as follows. So R is the shrinkage ratio, and it has been related to M sub S, V sub D, and rho W, and we have already defined these variables. If desired, calculate volumetric shrinkage as follows. V sub S is equal to R into V1 minus SL, where V sub S means the volumetric shrinkage, and W sub 1 over here is some given moisture content. So at any particular moisture content you can get the volumetric shrinkage. And the next is calculation of the linear shrinkage. So linear shrinkage is represented by L sub S, and this is the formula. So here you can see there is involvement of V sub S, and V sub S is the volumetric shrinkage that you can determine by using this formula. Now this is the last slide for this discussion. Estimation of shrinkage limit from plasticity chart. Knowing the plasticity index Pi and liquid limit, shrinkage limit can be determined from the plasticity chart as follows. If you just look at the modified form of the Casagrand's plasticity chart, we are having the U line, upon that we are having the A line. Let's say you have determined the liquid limit and the plasticity index for one particular soil, and your soil is this one at point A. Now just extend U line in this way, and by extending A line this way you are having the point of intersection, this is point B. Now from this point A, that is showing your soil, liquid limit and the plasticity index value, just join this point to this point B. So in this way you are having this point C on this scale. Now this value C is basically the shrinkage limit for this particular soil. So in this way, we can estimate the shrinkage limit from the plasticity chart. That's all about the shrinkage limit. Thank you.